I welcome you all for today's session, the next code conversion, that is our XS3 to BCD. So in the previous sessions we discussed about binary to gray and gray to binary, and now same like vice versa we are going to discuss about XS3 to BCD and BCD to XS3. As I said, we should know the difference between binary to BCD. In binary we will represent from 0 to 15. In BCD we will represent consider only from 0 to 9. So you can see here from XS3 to BCD means what we have to do. For in the previous section, like BCD to XS3, we have already discussed about BCD to XS3. In BCD to XS3, with all our BCD numbers, we have added additionally 3 with that BCD. If our BCD is 0 means we have to add 0 plus 3. So we will get 3. If our BCD is 1 means we have to add 1 plus 3. So we will get 4. Our BCD will be 4. If it is 2 means 2 plus 3, 5. 3 means 3 plus 3, 6. Then 4 means 4 plus 3, 7. Likewise, we have to add additionally 3 with each bit from 0 to 9, right? So here we have formed a truth table. Like that we have converted BCD to XS3. The same vice versa here from XS3 to BCD. So XS3 is your inputs and BCDs are your outputs. XS3 can be represented as E1, E2, E3, E4, and BCD can be represented as B1, B2, B3, B4. Okay, so the vice versa, like the previous, here also we have to interchange the truth table. Like our XS3 should be your inputs and BCD should be your outputs. Whatever we have converted in BCD to XS3, we have to interchange the truth tables. Like in BCD from 0 to 9, once if you add, we will get like 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. The same should be interchanged here. So what is your XS3, E1, E2, E3, E4? Your BCD, B1, B2, B3, B4. So this is the truth table. Once you interchange, you have to plot the K-map and find the output for B1, B2, B3, B4. After plotting the, your inputs will be, if your output is B1, your inputs will be G1, G2, G3, G4. Then output for B2, output for B3 and output for B4. So by plotting K-map, we can find the outputs of all B1, B2, B3. So here we have represented the inputs and outputs. After plotting the K-map, we have to draw the logic circuit like this. After plotting the K-map, we have to draw the logic circuits. So this is the logic circuit of your XS3 to binary. So your outputs are A, B, C, D. Here we have considered your gray inputs as W, X, Y, Z. W, X, Y, Z or your inputs, that is your XS3. It can also be, as I said, it is up to our users mindset. Okay, we can also consider this as E1, E2, E3, E4. If not, it is represented here as W, X, Y, Z. And your output, that is your BCD codes, are A, B, C, D. So in the previous slide, we have seen the truth table. For A, B, C, D, we have plotted K-map with the inputs and with the outputs. We have plotted the K-map, and this with the help of the K-map, we have a Boolean expression, and with the Boolean expression we have completed a logic circuit here. So this is the logic circuit of our XS3 to BCD. So your XS3 is W, X, Y, Z, and your BCD is A, B, C, D. See, this is the Boolean simplification. What is your A here? W, X, W, Y, Z. Then B is X dash Y dash plus X, Y, Z plus X, Z dash, and C y XOR z and d z bar. So with this boolean expressions, boolean equations, we have plotted this logic circuit. So with this we complete our code converters, all the 4 code converters. With this we complete all the code converters.